Hey, ladies and gentlemen, welcome to 9.7. Today, we are going to solve radical equations and inequalities. So our first example here says, computer chips are made from the element silicon, which is found in sand. Suppose a company that manufactures computer chips uses this formula, C equals 10n to the 1/3 plus 1500 to estimate the cost in dollars in producing n chips. What would it cost to produce that? So here, the nice thing is we know what n is. It's our 27,000. So we're just going to plug that in for n. So to solve for my cost, 10 times 27,000 to the 1/3 plus 1500. Now, remember 1/3 is a exponent. If you have an older calculator, you might have to put parentheses around it when you put it into your calculator, because we visited those rational exponents in our 9-6 notes. All right, when you type that in, you should find that cost to be about $1,800. All right, so we are going to look at ones where we have x inside our radical, or maybe sometimes it'll be outside. So let's go ahead and solve this. So our goal is to always get the radical isolated. So we're going to minus our 2 over first. So we get the square root of x plus 1 equals 2. Now that our radical is isolated, we can cancel the radical. So we're going to square both sides. That just cancels the radical and we leave it as x plus 1. And then we get equals 4. Go ahead and subtract the 1 over, so we get x equals 3. All right, and then this little blurb says, does your answer work? Check your answer, because don't forget, sometimes we obtain a solution that doesn't satisfy our original equation. Remember, that's called extraneous solution. When it plugs it back in, it doesn't work out, so then there's no solution. So if we plug 3 back in to x, we get 3 plus 1, which gives us 4. The square root of 4 plus 2, does that equal? So the square root of 4 is 2 plus 2, and that equals 4. So that does work out for us. Awesome. So then let's go ahead and look at problem 2 here. Now this one is a little different. We have a radical on both sides. So when we end up with a radical on both sides, we are first, you want to make sure one of them is isolated and the right side or the left side is. So we're going to square that. And then we're going to put this side in parentheses and square that also. So the square and the square root cancel and we get x minus 15 on the left side. But squaring on the right side means I have to times it by itself. And we just multiplied radical in binomials like this in what, 9.5, I think it was. This is not a conjugate because it's the exact same thing. So you need to FOIL or you need to box method that. So go ahead and just pause the video here and FOIL or box method that right side out. Okay, hopefully you paused it and you did that. So our left side stays. The right side became 9 minus 6 square root of, oh, not 3, square root of x, sorry, plus x. When we do this, now we're going to go ahead and our goal is to get all of our x's to the same side, our radical. Notice I have an x on both sides. That is going to cancel. If I minus it to one side, it's going to cancel. I'm going to minus my 9 over. So I get negative 24 equals negative 6 square root of x. At this step, our radical is by itself there. So I'm going to divide by a negative 6. And I get 4 equals the square root of x. So I want to get the x by itself. And I'm going to go ahead and square both sides. And when I square both sides, I get 16 equals x. If you take that back up and plug that back in, you find that it works out on both sides. All right, I want you to go ahead and do our first couple of steps for problem 3. And oh, you know what? My Smartboard lesson is missing something. It should have a negative there. There we go. All right, so the big thing with that is if I add 1 to both sides, I get the square root of x minus 2 equals a -4. That is one of those where we can't go any further. When you have a radical, you cannot take the square root of something and get -4. So we're going to say not possible. And we don't have to go any further. All right, so let's go ahead and give this next problem a try. Here it is still a radical equation, but it doesn't have a radical symbol in it, and that's okay. It's that exponent that shows up as a fraction. That's going to be our radical. So we still want to get that piece here without anything else around it. So we're going to go ahead and add 2 to both sides. So we have 3 times 5n minus 1 to the 1/3 equals 2. Now we're going to go ahead and divide both sides by 3. So we have 5n minus 1 to the 1/3 equals 2/3. And I put that in parentheses because we need to get rid of that 1/3. Now think about it. 1/3 power means the cube root. So we have to take things to the third power. These will cancel. So we get 5n minus 1. Now when you you get a fraction to an exponent, both the numerator and the denominator have to go to that exponent. All right, now we're going to go ahead and add 1 to both sides. So you can just go ahead and grab your calculator. Just put 8/27 in parentheses when you do this. And you're going to add 1 to that. And we get 35/27. All right, so we have 5n equals that. So I can divide my fraction by 5, or this is a possibility of multiplying by my reciprocal of 1/5. Multiplying by the fraction or the number, or dividing by a number, or multiplying by the reciprocal do the same thing. So when we type that into our calculator, you should get 7/27. All right, let's go ahead and move on. We have one here. This one is similar to our last one where we have an exponent, a rational exponent. So we're going to go ahead and isolate that by adding 2 to both sides. So we have 2y plus 6 to the 1/4 equals 2. I need to cancel my 1/4. It is the same thing as a 4th root, so I'm going to take it to the 4th power. Those cancel. So it gives me a 4th power over here. So 2y plus 6 equals 2 to the 4th. If we go ahead and do that or look at our list, we get 16. Now it's just a nice basic 2-step equation. We're going to subtract 6 to both sides. So 2y equals 10. That gives us y equals 5. If you plug that back in on your calculator, you'll find that that one is going to work out for you. All right, I want you to go ahead and pause the video here and give problem 6 a try. All right, could you pause it? I do want you to notice, if you thought about it, maybe some of you stopped right away and you had this and you said, oh, equals a negative, can't go. When you have a odd power for your radical, 5th root, 3rd root, 7th root, we have talked about those can give you a negative answer. So this is okay. So if you stopped here, keep going, please. All right, hopefully you went through, we did -5 to the 3rd power. That gives us -125. And then we're going to subtract the 1 over and get 3y equals -126. So y equals -42. All right. So we are going to now start solving some inequalities. And with the inequality, we're going to have to do a couple extra things. So let's look at this first one. I'm going to go ahead and, oops, again, I'm missing something here that's in your notes, a negative. All right, so I'm going to go ahead and add 2 to both sides. So the square root of 4x minus 4 is less than or equal to negative 4. All right, so when we do this one here, we are not going to get a square root of something and it ends up being less than a negative. So we are going to not have to go further with that one. So, ooh, that's a good reminder. When we multiply or divide by a negative number, you must flip the symbol, the inequality sign. So let's go ahead and look at our first one here. We're going to minus the 1 over. So we get the square root of 2x plus 2 is greater than or equal to 4. Okay, this is working great. We're going to square both sides. So we get 2x plus 2 is greater than 16. We're going to go ahead and minus our 2 over to both sides, and we get 2x is greater than or equal to 14. So therefore, x is greater than or equal to 7. And so what this is saying is I can plug any number 7 or bigger into this problem, and it's going to give me a solution that is bigger than or equal to 5. Once I go smaller than 7, it is no longer going to simplify to that inequality. So this one is a minimum, and I don't need to go any further with it. That is going to be my answer. If we look at our next problem, we have a less than symbol here. So that is going to affect some things as we go. And let's go ahead and start off by adding 2 to both sides. So we get the square root of 4x minus 4 is less than 6. We're going to square both sides. So 4x minus 4 is less than 36. Go ahead and add 4 to both sides. So 4x is less than 40. And when we divide by 4 on both sides, our inequality symbol stays the same and it becomes 10. So x needs to be smaller than 10 to get an answer that is less than 4. But here's where the kicker is. That's a maximum. I can't go bigger than 10. But let's think about, as you put in smaller numbers, eventually you're going to get to the point that is going to be less than like a negative number underneath that radical. And we can't have a negative number under that radical. We end up with imaginary numbers. So we need to have a minimum. And this is how we're going to find our minimum. We're going to use our radicand. That's how we found our minimum when we graphed them in Unit 8. So we're going to take our 4x minus 4 is greater than or equal to 0. Remember, that's how we found our minimum for our domain. And so we're going to go ahead and add 4 to both sides. And then we're going to divide by 1. So x needs to be greater than or equal to 1. And it needs to be less than 10. That is what is going to go ahead and satisfy to give us an answer that's less than 4. All right, go ahead and pause the video here and plug or try problem 10 out and see how that goes. Okay, so hopefully you guys were able to go through and solve that. Minus the 4 over, square both sides, add 6, and then divide by 3. So we get x is less than or equal to 5. That's a maximum. So we need to go back in and do our job and find the minimum. So again, we're going to take our radicand. 3x minus 6 is greater than or equal to 0. This is going to find me my minimum for my domain. So I'm going to add 6 over. And I get x is greater than or equal to 2. So your numbers are going to be between 2 and 5 are the only ones that satisfy that end up with something less than or equal to 7. All right, we got one more here, ladies and gentlemen. Ponderous index P is a measure of a person's body based on height in meters and mass in kilograms. One such formula is P equals the cube root of m over h. A 70-kilogram person is 1.8 meters tall, has a ponderal index of about 2.29. How much weight could such a person gain and still have an index of at most 2.4? Okay, so at Most means that what we're dealing with needs to be less than or equal to 2.4. Okay, their height is not going to change, so we keep that at 1.8. Then we're going to solve for m, and that's going to help us find out how much more weight they could gain. So we're going to start off by timesing both sides by 1.8. So that'll cancel there. All right, go ahead and grab your calculator and put that in. All right, so we got 4.32 here, and this is a cube root, so we're going to cube both sides. So grabbing that calculator and cubing both sides, we get m is less than or equal to 80.62 kilograms. But the question says, how much weight could such a person gain? So what we're going to do is we're going to subtract the 70 that they are. And so when we do that, they're going to have less than or equal to 10.62 kilograms is how much they could gain and still be within that same ponderal index. All right. Well, there you have it, ladies and gentlemen. Have a great rest of your day after you finish your homework.